Hello everybody, welcome to our lesson, Natural Science, Grade 8, Week 2, Lesson 2. I did put on our chat the ground rules, so I would like all of you to adhere to them. Please chat only about lesson content, otherwise you will be removed by our host. At the end of this lesson, we're going to learn about you should know more about the particle model of matter. You'd learn more about diffusion, the changes of state, evaporation, condensation, freezing, and melting. Now, before we go on, would anybody like to tell me what they've learned from yesterday when we discussed matter, mixtures, and pure substances? Is there anybody that would like to? You can raise your hand and I will ask the host to unmute you. Yes, Caitlin.
A pure substance is made up of only one kind of particle, and it is a fixed or constant structure.
Oh, that's very good. Well done. Can anyone tell me about compounds? Caitlin was absolutely correct with that. Anyone with compounds? Yes, Joshua? I host will unmute you just now. Joshua? Okay, so I will tell you compounds are made up of elements. Two elements, and they can be diffused. Can be diffused means that it can change its state by either electrolysis or heating. Right, so we're going to continue. We're going to discuss the particle model of molecules. Now we're going to ask of matter. We're going to ask the question. Now, what is particle model of matter? So this model is best described in a scientific way, explaining what we experience with our senses, like basically what we see, what we feel, what we hear, what we smell. So basically, remember when we went earlier on, I told you that all matter is made up of materials. Matter is everywhere. So matter is everything that you feel, that you see, that you hear, and you see, and you feel. So we're going to go into our lesson describing what these particles are made up of. The particle model of matter scientifically explains why matter behaves the way it does. It tells us the following. It tells us that all matter consists of small particles, that these spaces between the particles are empty. Now, when we say that the spaces between the particles are empty, this means basically that there is nothing between the spaces, not even air. So when we say it is empty, that means that there is nothing between them, not even any air, because air is a form of gas. Right, the particles are continuously in motion. In motion means that it continuously moves. Now, there are repulsive and attractive forces between the particles. That means some particles repel each other, like where we said that the protons, they repel each other. And then we have the attractive forces where we have the electrons and the protons attracting each other. So we are going to ask yourself, now, why is the particle matter so important for us to learn? Why should we learn about it? Now, the particle matter is useful because it describes matter in its three states. So you were introduced earlier on in your schooling career that you had matter as in the form of a solid, in form of a liquid, and in a form of a gas. And it goes through processes like condensation, evaporation, melting, freezing, And later on, I'm going to explain these two processes to you called deposition and sublimation. Okay, Diego, you have your hands raised. Can I help you with anything? I'll ask my host to
Um,
unmute you. Yes?
yes, ma'am, could you please slow down, please?
Okay, I will try and go slower, but you also need to understand that I have to complete the lesson content that I have. So if you think that I need to go slower, then you may just raise your hand and I will slow down a bit. But you can also access all this content later on YouTube, because you can watch it and rewatch it, which would make your learning easier. And if you want later on, you can send me an email and I will email you the slides so you can learn. But when I explain it, if you go on YouTube, with the explanation as well, you can download the videos and you can keep and store them on your hard drive.
Okay,
Okay,
thank you,
so
ma'am.
understanding, hi, okay, understanding how the particles of matter behave is vital if we hope to understand science. Now, the model as also helps us to understand what happens in the particles when matter changes from one state to another. So we want to know basically what happens to the particles in let's take water for an example. Water is in a liquid here. What happens to it when it changes to a gas? And what happens to it when it changes to a solid? So what happens is basically it goes through certain processes. Now, if we apply the process of evaporation on water, that means when we heat water, it basically forms tiny droplets of water vapor, which is a gas. Now, if these gases cool down and they form together, this means that it is going through a process of condensation. And now, if we had to take this liquid and if we had to freeze it, then it would become a solid. So the particles have changed. Like here, the particles are all close together in a fixed position. Here, the particles move around each other and it does not have a definite shape. And in the gas, they are free to move around. So I'm going to give you I'm going to explain a little bit of this here. Did you know that under special circumstances, a solid can change directly into a gas without melting? So now, remember I told you that I was going to explain what sublimation means? So basically, sublimation is when a solid can change directly into a gas without melting. So I'm going to repeat it. Sublimation is a process when a solid changes directly into a gas, and this process is called sublimation. So the reverse is also true when we use the term deposition. Deposition means that um, a gas changes directly into a solid without condensing. That means that a gas changes directly into a solid without becoming water first. Okay, so these are two new words that you need to learn, deposition and sublimation. Does anybody want to tell me what I just said about deposition and sublimation? It will help by if you tell me, then it will help to slow down and then you can understand better. Yes, can I ask my host to unmute you? Yes, hi. Do you know what deposition and sublimation is?
Sublimation is known as a process, and it is when gas changes directly into a solid without condensating it first.
Okay, that is when a solid changes directly to a gas. So sublimation is when a solid changes to a gas. And then what would deposition mean? So does anybody know? Okay, so deposition is the opposite of sublimation. So if sublimation is a solid changing to a gas, then deposition means a gas changing to a solid without condensing. Okay, so I'm going to explain more about the three phases of matter. So in the first block box over here, we have a solid, and the second one is a liquid, and then the third one is a gas. So now I'm going to tell you some of the properties of a solid. Now particles are packed closely together. So you can see each particle here, it's packed closely together. Now the particles do not move, but they do vibrate. Now earlier on in the earlier slide, I said that between the particles, there were spaces between. So can you see these spaces between each particle? So these spaces that are here are not any form of gas. It's not any air. It's just empty spaces that are between each particle. And this allows the solid to vibrate. Okay, now the strong forces holding particles together, they are strong forces. That's the attractive forces that hold them together. And I see two people wanted to speak. Can I ask my host to unmute you? Yes. Hi. Oh, hello.
Hello.
Hi.
I wanted to ask about the solid arrangement.
Okay.
So it's basically kind of like a fence, and then after the people inside who are closely packed together and doesn't move anywhere, it just stays where it is.
Yes, it just
The
stays where
liquid
it is.
and the liquid one is kind of like marbles moving around together.
Yes, like if you watched on TikTok, the new videos that they're showing you is how to wash your hands, and then they
Yeah.
tell you to wrap your hands around each other. So this is how the particles in a liquid move. They move around each other. It's not in a definite
Then the gas
shape.
then the gas particles is basically like bubbles because they move around everywhere.
Yes, there's less space between them here, so they're free to
Okay.
move around. That's very good. Well done. Okay, so now I know that you understand the lessons of the distinctions between solid, liquid, and gas. Now, I'll give other people to speak in another slide because I'd like to move on. Particles are loosely arranged. Particles move fast and they slide past each other. Now, particles have weaker forces between them and small spaces between them. So this is a liquid. So now in the solid, we had that there were strong forces holding each particle next to each other. But in a liquid, they have weaker forces and there is a little bit more space between the particles than in a solid. And here in this liquid, the particles move around fast. Then we have the gas, and the gas is the particles have no arrangement. That means that there's no fixed place where it can be, and they're far apart. And they moved very, very fast, which means that there's lots of energy between these particles. And it has a weak force between them. So between each particle, it has a weak force between each one. Okay. So now if we look at this dustbin here, now when we look at the dustbin, we could say that, and if you walk past dustbins, especially like the one that you see here, it's been um, uh, basically smelly because dustbins like this basically are left over time and for dirt to collect. And now have you ever noticed that when you walk past it, that the smell of it travels very quickly and you can smell all the rubbish in the dustbin? Similarly, like if you have played around with stink bombs, or you wanted to prank someone, and in the stink bomb, when it blew up, now this stink bomb reached your nose very, very quickly. So now this is a process of diffusion. Would anyone, I see someone wanted to raise their hand and ask me a question. Yes, can I help you? Hi. Okay, I will continue, and then when you are unmuted, I will speak to you. Now, most smell travels because of their particles mixes with air, and they get to your nose that when we breathe. And we say that the particles diffuse through the air. So I want you to become familiar with this new word, diffuse. Diffuse means that when the particles are mixes with air, like from a certain place, like for example in the dustbin or a stink bomb, and or like when your mom or your dad is cooking. So the scent from whatever they're cooking is now being diffused into the air, and it reaches your nose. Okay, so the proper scientific definition of diffusion is a process in which particles in liquids and gases move. That means that they separate and they spread. So when we say it is a process in which liquids and gases move, that means that the liquids and the gases separate and it spreads around from a high concentration area to a lower concentration area. So like if you go into your kitchen and you can see a pot of food cooking, the scent of where the food is cooking is where the pot is. So that is a high concentration area. And then this scent would carry over into your lounge or into your dining room. And this is a low concentration area. So diffusion is a process in which particles in liquids and gases spread. That means it moves from high concentration to a low concentration. So now I'm going to explain to you about, you look at the glasses. The glasses here are basically clear water, and then we see water mixed with a yellow substance, and then we're going to see the water mixing further down. Now it hasn't been stirred, that the yellow substance here has just been put on top, and I'm going to explain how diffusion works through this. Right, so in grade 7, you learned about different mixtures, and in this investigation, we're going to explore whether particles mix faster when they are in a liquid state or in a gas state. And then this would be called the rate of diffusion. So that's another concept you need to learn, rate of diffusion, and I will give you that definition now. So when we talk about rate, we are measuring how something changes in relation to another factor, such as time. Like another example could be speed. Now it is measured in kilometers per hour. So we could say how, if we say a cyclist is cycling. So we would take how many kilometers did he cycle in 1 hour. So this is called rate of how distance in kilometers changes over a period of time. So we apply the same thing to rate of diffusion. We could say how the substance has diffused into the air over a period of time. So how how the mixture changes also in relation to another factor. So in the photos, you will see that the yellow liquid is being added to the colorless liquid. And then you will notice that the liquid swirls and spreads as the yellow particles mixes with the colorless particles. So now this yellow liquid here is actually swirling down to the bottom. So first somebody just dropped it in, then over time it is mixing with the water. Let's say it's yellow coloring. So it mixes and it goes down into the glass. And we could say that that yellow substance now has diffused into water. It has spread into water. So what will the mixture look like when the colored particles are uniformly spread out amongst the water molecules? So now we want to know, now right now you will see that this yellow liquid, you could see where I'm pointing here, it is gradually spreading through the glass, but it's not uniform. Uniform means that it is not consistent. um, you still can see water, you still see the yellow substance, and then you can still see the clear water. It is separated. So now we're going to look at what will happen when these particles are uniformly spread out. Okay. And then we're going to also ask the question, what will the mixing process look like at a particle level? So now, basically, instead of me showing you that clear water with the yellow mixture, we're going to do it on a particle level. So we see water as being particles here, and then the yellow substance, it is in a high concentration here. So now we want to see how it will spread out when it is mixed through um, the whole glass of water. Yes, Jade, how can I help you? Can I ask my host to unmute Jade?
Yeah, I wanted to ask about, is there such a thing as controlled diffusion? Because when you spray perfume, that that amount of spray that you sprayed, that's the amount that spreads out. And then when you don't spray the perfume anymore, it doesn't smell as strong as it is when you spray it. Is there such a thing in natural science?
Okay, so what I want to do is I want to explain just the process of diffusion, and then as we go later on, you'll understand a little bit better of um, controlled diffusion. Depends on how much of substance that you would put into it. So you're only controlling the amount you want to diffuse, like in this yellow substance here. So in controlling means that you will only control the amount that you are putting it in. So as I go through this section here, you will see that how you're going to spread this substance from a large concentration into a smaller, um, lower concentration. So the whole thing would be diffused. Now, controlling means that you only have put a certain amount of yellow substance in it. You didn't put a lot. So because you can, if we actually just count it, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically there's 10 particles here. So you want to see how this 10 particles is diffused through all these molecules in here. So the following diagram represents the one glass that we have pictured above. Okay. And now the yellow liquid represents the yellow circles, and the colorless liquid represents the water. The blue colorless circles here represents the water. Now the glass on the left shows the particles in the mixture directly after the yellow was added in here. So it was highly concentrated there. Now the glass on the right here is empty. Now this is an activity that I want you to do. I want you to draw the particles. You can do it on a piece of paper on your desk as well. On the empty glass, you can draw an empty cylinder as well. And I want you to see how this mixture has spread uniformly throughout. Now the idea I can give you is basically when you take a glass of water and if you put sugar into it. Now the sugar sits directly at the bottom of the glass, right? It is not diffused. But when you take a teaspoon and you start stirring the sugar, you will gradually see that the sugar is being dissolved and it diffuses through the whole water and it makes a new substance called sugar water. So when we say uniformly spread into this colorless liquid, we mean like how sugar dissolves in water. That means it is equally concentrated throughout. So how do you think that these 10 marbles would be diffused in an empty glass? I someone wanted to see chat, yes?
Ma'am,
Hi.
I want to ask about that example you just said of sugar. What's the method you call when you stir sugar to help it dissolve in?
So basically it's stirring. The method is stirring and you diffusing the sugar into the liquid water. So the method that you're using to diffuse it is actually stirring. Okay. Anyone else? Okay, so if you had drawn it, you would basically see that now this yellow substance is
Ma'am,
going to, hi,
ma'am, how come there are so many particles in the liquid? Normally they're not so close together in the diagram you showed us earlier.
because I wanted to explain the particle part. Basically, liquid, the diagram I showed you earlier is just a representation to show you that they are loosely packed together. Now in this diagram, because it is closely packed, but it's not in a uniform way. Can you see? Now in a
Yes,
solid,
ma'am.
when they were closely packed, they were in a uniform way. But here, it's not in a uniform way, so it's just more liquid in there. Okay. So
Thank you,
now
ma'am.
when we, no problem. When you put in this yellow substance here, now if you wanted uniform, it's basically going to go, say, one here, then one here, then, uh, well, not uniform, but say, yeah, one here. And so we're spreading it basically evenly around. So it will basically mix. Okay. So when it mixes, it'll be, uh, gosh, I'm not sure what happened here. When it mixes, it would become, okay, sorry, that was a temporary glitch. It will become more uniform. So now I'm going to explain this further as to how the particles move with this diagram that I have here at the bottom. Okay, so you can see before I start, you could see point A here, and then you could see point B there. Right. So particles in a liquid and gases, they constantly move and their movements are unpredictable. So in liquids and gases, because it is not in a definite shape, they constantly moving in an unpredictable way. Unpredictable way means that we actually don't know in which direction it's going to move. So we say that the particles move randomly. So if you take a bottle of water and if you shake it, then you could see that the water is moving randomly. It's not moving in a specific direction. And this random movement of particles will allow liquids and gaseous substances to diffuse. So if you had to, you can do this experiment at home. You could take, say, half a 250 bottle of water, and if you can add just half, don't waste the water, just add half of the bottle and take some food coloring in. And then you will notice that the food coloring will just sit in one place. But then if you shake it, or even you close the bottle first, and if you shake it, then you will see that the yellow food coloring diffuses, and then the liquid, because it's transparent, you used water, now becomes yellow. So this is a random movement. It doesn't move in a specific order. Okay. And then we're going to follow the following zigzag diagram explains what is meant by random movement. I'm going to, my host will unmute you just now, Najlashla. So let me explain this first and then I'll ask him to unmute you. So the zigzag movement shows that the random movement here. When a gas particle travels from point A to B, so you could see that this random movement of point A to B, it's not in a specific uniform movement. And then while they are moving, it collides with many other particles along the way. And there are up to 8 billion collisions per second. So this box here that I showed you only represents a small piece of how it is moving. It is much more rapid. But by the words that I used, up to 8 billion collisions per second can tell you exactly how fast it is moving. And you'd notice that when you shake the bottle of water as well, it's rapidly moving up and down. The representation here is just a small representation to show you how it can go. And only a few of these collisions are shown in the diagram. And each time the particles will collide, it changes its direction. So it doesn't specifically mean that the particles will actually move the same direction, in the same direction, meaning that it will move in a uniform way, like from left to right. It can just change its direction. So this means that the actual distance traveled by the particles is much further than the distance traveled from A to B. So it could be the particles will move in any direction. So the learners that have raised their hands, you can ask me a question now. I can ask my host to unmute you. I think it was Lanchla and Cindy.
So,
Ma'am,
Yes.
when you so the factors that affect the diffusion is just like when you learn about things which can dissolve and things which can't dissolve. The soluble that you're using is what will also depend what will also affect the diffusion.
Yes, very good. That's very, very good. The fact that the substances that you are using affects the rate of diffusion. That's excellent. Well done. Anyone else?
ma'am, when you
Yes.
use the example for the bottle, when you with the diffusion, when you shake it, does it speed up the mixture? Does it speed it up? Will it still mix and diffuse if you don't shake it?
Remember in the slide earlier on I showed you here, I'll go back to it. Here, these glasses.
Yeah.
Now, if we just dropped the yellow liquid, can you see that the rate of diffusion is slow? It diffuses slowly on its own. But now if you're shaking it, you're actually increasing the rate of diffusion. That means it will diffuse much more quickly. Do you understand? Does that make more sense to you now?
Yeah.
Now,
So
like
it will still diffuse, but more
yes,
slowly.
yes, it will diffuse, but much more slowly than um, uh, it's going on its own. So the rate of diffusion by, say, shaking or stirring has increased by using that process. Okay.
Okay. Thank you.
No problem. So I'll just start here. This means the actual distance traveled in the particle is much further, and we can also say than points A to B. So I'll move on to explain diffusion further here as well. So now can you see that these particles, they concentrated in a particular space? So basically we could say we can use that example as being sugar, because when you put salt or sugar in water, it just goes to the bottom. So the particles here at the bottom, yes, may I ask my host to unmute you? Hi.
In the first class of the example you're showing us, that would be like if someone just takes a spoon of food coloring, for example, and just puts it, then it will fall onto one side of the container. Then in the second one, it would be you shaking the material into the glass, like when you're shaking salt into the glass.
Yes.
Okay.
So Remember, like in here, if we put the salt or the sugar here, but now we're going to use a process such as either shaking or stirring to diffuse this. And then you get this uniform diffusion of the particles going throughout the water. So you could see now it's going from a high concentration to a lower concentration because it is now spaced out. Okay. Okay. So now, yesterday my lesson went really, really long because I was trying to complete the content that was in the slide. But I think that this is more interactive where you ask me questions and then it makes more sense to you. So if we don't finish the slide because we can only be 45 minutes on, then I will continue with it in our lesson tomorrow. Is that fine with you? It will just take I'll just take the lesson content that I didn't finish and put it into tomorrow's lessons. And I'll do a recap in it because I think this way is much more better instead of me just explaining everything. Is that fine with you?
Yes, ma'am.
Okay. Okay. Right. So now let me explain this first. Now, the process responsible for mixing and spreading the particles in a gas and a liquid is called diffusion. So now, if they ask you in a test, now one explains diffusion, and if they give you an example like this, then you would say that there's or they ask you what diffuses basically a substance in water, then you would say there's a process that is responsible for mixing and spreading the particles. So if you put, as the other learner said earlier, if you just put some yellow liquid in water, then it will slowly diffuse on its own, but it won't diffuse evenly, uniformly. So if we apply a process such as shaking or stirring, uh, uh, and this is mixing and spreading the particles, then this increases the rate of diffusion. So we can define diffusion as the random movement of liquid or gas particles from a high concentration to a low concentration to spread evenly. So here it is in a high concentration. Now if we apply a process of mixing, then we spread the particles evenly. Okay. Right, so the following diagram illustrates the idea in a very simple way. It shows that the particles in a gas is spreading out over time to fill all the space that it is available. So now in this cylinder here, we're using gas, right? So first the gas was here all in one high concentration, and over time, let's say we closed the container, then the gas spread out, it moved, and as it moved in a even uniform distribution all over, so that the gas is evenly, not well, more or less evenly distributed throughout the container. So if we look in the diagram on the left, some particles are placed into the empty container. And at first they were close together, which is the high concentration. But over time, it spread to fill the entire container. So now there are factors that affect the rate at which particles diffuse. Yes, Tia. My host will unmute you. Tia. Hi.
Hi, ma'am. One question. Don't particles also vibrate at different speeds?
Yes, the particles do vibrate, but then we have factors that would cause it to vibrate. And then we could go on into it later, that when we see what are the factors that cause it to diffuse. So I'm going to do this now, the factors that affect the rate of diffusion. So it does diffuse at different speeds, and it's because the factors cause it to diffuse. Remember that in the previous slides, I said that the particles diffuse when you add mixing or you add a process of it diffusing. Now we're going to discuss the factors that affect the rate of diffusion. Okay, so
Thank you,
now
ma'am.
you're welcome. So these factors are the mass of the particles. Now, for example, we have lighter particles will diffuse faster because on average they move faster. Like for example, what can I use? Well, basically air in front of you. So if you flap your hand in front of you and if you move it really fast, you can see that it causes some kind of wind in front of you. So now this is basically the air is a lighter particle and it can diffuse fast. And now the air that you are moving in front of you is basically also now you have caused it to diffuse in a random motion. Okay. Would anybody like to ask me a question? Yes.
Ma'am, isn't it during the process of diffusion, there's also like there's a certain rate which is reached. I'm not sure, but it's called like equilibrium, if I'm right.
Equilibrium would be like when I'll relate it to the glass of water, the yellow substance that we poured in. So the water, the yellow substance was equally distributed around the water. So that
Okay.
would be equilibrium. That's it. That's correct. Well done. I see you've been doing some reading and learning.
Thank you,
So it
ma'am.
is, you're welcome. I'm very proud of you. Well done. So we have the state of particles. The particles in a gas are always moving fast. We say that an average speed is high. So when the gas particles move fast, we say it has an average speed. And this would be like the rate of diffusion that I spoke earlier on. So it has a speed in which it is moving. And remember that when I discussed atoms in previous lessons, we said electrons move around the nucleus in a very fast way. And when they move around it, in the nucleus, it forms clouds. And that's how fast that it is that it moves. So one of the factors that affect it is basically speed. And then the particles in a liquid, they travel more slowly in a gas. Now, why the particles in a gas would travel fast is because they are not uniformly and random. It does not have a definite shape. They're not stuck next to each other. But in a liquid, it is more, in the gas, they're more free. They are far apart. But now in a liquid, they are closer together. Like remember, I showed you when you wash your hands, the particles are uh, can move around each other freely, and they're a little bit more concentrated. Hi, I can see some learners raise their hands. Okay, so I'm going to continue. The temperatures of the particles, this is another factor. So the temperature affects the rate of diffusion. So the temperature is a measure of kinetic energy of the particles. The higher the temperature, the more energy of particles they have and the faster that they will move and diffuse. So that means heat. So if we apply heat to a substance, that means that you're increasing the temperature and the particles will move faster and they will diffuse faster. Like for example, if you had to watch your kettle boil, so and let's say you had the lid off. So now you would see that the water, as the water, you apply more and more heat, that means you're raising the temperature, the bubbles go from little to faster and faster. And then you see water vapor coming out. And initially it will be less, but as the temperature increases, the water vapor is a lot more. So this increase of temperature causes affects the rate of diffusion as well. Okay, and then the size of the particles, also the size of the spaces between the particles. So now remember, in a solid there were spaces between it, and then in a liquid the spaces between the particles were a lot more, and in a gas there's a lot of space between the particles. And if you have large spaces between the particles of one substance, then the particles of another substance can move into those spaces much more easily. So if we looked at this slide here, can you tell me what are the factors that affect the rate of diffusion? Can anybody tell me? I'll ask my host to unmute you. Hi.
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 I just have a question.
Okay.
Ma'am, you said the factors that affect the rate at which the particles diffuse. I just want to know, what are the factors that cause particles to diffuse? Is it air currents in gases, or is it water currents in water?
So for grade 8, we're learning just the basics of the factors that affect the rate of diffusion. So now I've noticed as I've been teaching, I want to go at a slow stage and introduce this to learners instead of confusing them. So can we do that a bit later?
We can? Yes. Okay, thank you very much.
No problem. So now the mass of the particles as one of the factors. Then we have the state of the particles is another factor. Then we have the temperature of the particles, and then we have the size of the particles that affect the factors that affect diffusion. Okay. So now particles diffuse because they are basically in a constant motion. Now, if you look at this crowd of people, and they are really, really close together, they're standing each other. So let's see how this works. So gas particles diffuse much more quickly than liquid particles. So basically, that's because the gas particles are far apart. And now, can you explain diffusion in a liquid using the factors that we listed above? I want you to think about this. Yes? Hi? Okay. Now, this slide, hello? Okay. So now think of it in this way. Imagine you are trying to move through a crowd of people, which is here. Let's see how the closer they are together, that means that the closer number of people are together, the more often they are going to change the direction to make it through the crowd. So now basically remember that I said that the particles move in a zigzag fashion. So now if people are standing, you can't just like bump into the person because it would be rude. Okay, so now you have to find a way of going through it. So now the closer they are together, the more you have going to change the direction. So this is the reason why the particles move in, because they change directions so that they don't bump into other particles. And they make it to the part. So sometimes it would take longer to get to that destination. Okay, so now if we look at how the particles move, it moves in a liquid in this way because the liquid particles are much closer to each other here, and then the gas particles are spread out, so it is easier for the particles to move and they don't bump and collide into each other because they are further apart. Okay, so liquid in a particle in a liquid cannot hi. it cannot travel very far before colliding with another particle because the particles are very close together, which is what I explained to you. This means that the liquid particles are constantly colliding and are sent into a new direction with each collision. So with each collision, they basically change direction and they move in a new direction. And this means that the rate of diffusion is much slower in liquids than in gases. So now rate of diffusion is slower than it is in gases because the particles bump into each other. And in gases, the particles are further apart and they can collide less. Now, gas particles can travel further without being sent in different directions by a collision. And this is why gases move more quickly. Okay. Now, the table below here, it shows the zigzag fashions, which is what I explained earlier before I introduced this topic. And you'll be able to see the difference between the random movements of a particle through a liquid and through a gas. And it will take the particles much longer in the liquid to go from point A to B than it would take to go in a gas from A to B. Would anybody like to ask me a question? Now, because our tutorials are actually 45 minutes, the lessons that information of change of state I'm actually going to do tomorrow. So I'm going to sum up with everything that I did so far in so change of state we'll actually do tomorrow, but what I'd like to do is the key points so I can sum up of what we discussed so far. Hi, can I ask you a question? Can I answer your question? Can I ask my host to unmute you?
Ma'am, by
Yes.
the solid with the particles, why do they vibrate?
In a solid, because they next to each other. Remember that I told you, like for example, you had protons. Basically, I'm going to use that example of protons to explain it. So protons basically repel each other, and because they repel each other and they're next to each other, the solid it causes it to vibrate because they're right next to each other. And remember how we had neutrons in the protons that softened the blow, so it doesn't collide with each other. Now think of it being in a solid with these particles right next to each other. So it causes it, because it's next to each other, it causes it to vibrate. Do you understand that?
Yeah, I understand now.
Okay. Okay, so now to sum up what I did so far is that all matter can be described in terms of particles it consists of and how they are arranged. They are extremely small particles and they are called atoms or molecules, and depending on the type of material. The theory that describes matter in terms of particles is called the particle model of matter. Now, it will help you to understand that microscopic properties of a material in terms of behavior. So basically what this I just said is that the theory of understanding the particle model basically helps you to understand how solids, how liquids, and how gases behave. So the particle model in a solid, they are closely packed to each other and they locked in a fixed position. And the only movement they are is that they have is vibration. So these strong forces causes the vibration that holds it together, and the spaces between them are very small. And now particles in a liquid, they are close together, but they're not in a fixed position. They are in a constant motion and they slide past each other. And they hold each other in a moderately strong force. And the spaces between them are very, very small. So Now, in gases, they're in a constant motion and they're not arranged in a they are free to move. They're not arranged in a fixed way, and the forces between them are weak, and they are far apart, and there's lots of spaces between them. Right, and now since the particles of a liquid and solid are in a constant motion, they're able to diffuse. And diffusion is a process in which particles spread out through random movement, which is from high concentration to low concentration until it is evenly distributed. So this is very important. Okay. And now, when two substances mixed, their particles intermingle until their consumption is uniform throughout. So basically, this means that when you mix two particles, that you mix it right until it becomes uniform throughout. And now this is called diffusion. And the process is much faster than in gases than in liquids, because in gases the particles are far apart. Okay, so now changes of state is what we're going to do tomorrow. I really enjoyed this lesson. We derived all the information from the natural science workbooks that the Department of Education has provided online for us. Danielle de Eck is our science supervisor, and she has helped me compose some of the modules and I actually slides, and I actually did use some of her slides that she uses in her teaching. You can visit this YouTube address here, which explains the states of matter, and this YouTube address here, which explains the diffusion and also the rate of diffusion. They're really good YouTube videos for you to visit. You can either take a screenshot of it or copy it down and leave it for a few seconds on.